So, welcome to a quick review of the answers for our 7.1 to 7.3 review. The first question is asking you about the number of chips in a delicious batch of JP's double delicious chocolate chip cookies. So, the information that you're going to need to get out of this here is that we have N 40 cookies. That's that's our sample number, and then this is X bar. That's the average number of chocolate chips in these delicious morsels here. And then finally, we've got the sample standard deviation, which is S. Now it says, construct a 95% confidence interval for the number of chips in these culinary works of art, temperature interval, and words related to the problem. Now, when you do these things, you're going to have to decide what parameter you're trying to estimate. And you've got three choices. You've got a choice of mu for population mean. You've got a choice of sigma for population standard deviation, or a choice of p for population proportion. Now when you look at this, the number of chips in there doesn't have the feel of a standard deviation. It's not talking about how many chips vary from cookie to cookie, what that standard deviation is, nor is it talking about the proportion of chips. There's no proportion here. It's not like there's 40 chips maximum and then this is the number of chips and proportion. It's just the number of chips. So you kind of get worked down to the mean here. That's the only one left. So by process of elimination, you're going to construct the 95% confidence interval for the population mean. So we're going to take these summary statistics and put them into StatDisk. So let's click over here. You're going to go to the analysis menu, down to confidence intervals. You want to mean one sample. Okay. Let's put in the numbers here. Confidence level is 0.95. Sample size was 40. The sample mean was 26.4. And the sample standard deviation should be 2.55. Now it's important here, it's asking you, do you know the population standard deviation? The answer to that in this course, and probably for the rest of your life really, should be no. If we knew what the standard deviation was, the population standard deviation was, that means we have all the data and we calculate sigma. But if we have all the data and we can calculate sigma, then we could calculate mu. And we wouldn't need a confidence interval for mu. So it's silly to think that we would somehow know this and not know this. So when you're working with that menu, you should never be putting anything in here for the population standard deviation. Let's keep on working. So let's evaluate here. We get a margin of error of about 0.8. Here's your confidence interval. If I round that off to 25.6 and 27.2, which is fine, I'll tell you where I care about that. Then what you can state is that we can be 95% confident that the true mean number of chips is between 25.6 and 27.2 per cookie. So great. If I wanted to compare this to the number of cookies that, or the number of chips that are in a Chips Ahoy cookie on average, their number was 23.95. If you look at our interval, that interval is above this. So two things to note. First of all, this doesn't fall in this interval, so they're different. Second is that this is below my confidence interval, so yeah, I can say that, you know, I've got more chips in my cookies than Chips Ahoy does in their cookies. So, hey, all done with number one. I got a lot of questions when we were going through this about number 2, part A. So that would be this one right here, number 2. And part A, they're just asking for the best point estimate of the percentage of people who know what Instagram is. Well, here's the secret in that. It's right there. There's your best point estimate. That's your best guess. It's just one number. Now, if you wanted to be a little bit more confident about where this number could be, then you're going to surround it with a confidence interval. And in this case, since you're talking about a percentage or a proportion, we're going to do a confidence interval for a population proportion. The challenge you're going to run into when you do that is that in StatDisk, you need to fill out what X is. Now, X is the number of successes. Okay, so looking good there. N is the number of trials. Our number of successes is 91% of 1,007. And when you do that, well, that's 0.91 times 1,007, and that'd be 916.37. There's a problem. If you try and put that in StatDisk, it's not going to like it because this isn't, a valid input. You can't have 0.37 of a people knowing what Instagram is. So the best thing to do is to go with the fact that this is approximately 916. We're going to go with the nearest integer in this case. Now, there is another case later on in the course where we would round down or round up always, but in this case we're just going to round to the nearest number. If you put that in along with your level of confidence, 99%, and X is 916, and N is 1,007, you'll get this confidence interval here. Once again, as you interpret your confidence interval, we can be 99% confident that the true percentage, so that's something that I'm always going to demand when I look at these types of problems and your conclusion, is that you describe the parameter. By saying true percentage, you're really saying this. You're just saying it in a nice user-friendly way that somebody can understand, even if they don't understand statistics and really appreciate what a parameter is. True percentage of, now you have to have words that go back to the problem. People who have heard of Instagram. And finally, the range of those values. Now let's take a look at putting that in to StatDisk. So let's go to confidence intervals, proportion one sample, want a 99% confidence interval. Sample size was 1,007, and we had 916 successes. Nice. So here's your confidence interval. We stated that, wrote down our conclusion, that's fine. But what would happen if we dialed this down to a 95% confidence interval? I want you to take a look at the margin for error. Let's take a look at what happens here. Oh, it went down, didn't it? In fact, the width of this interval also went down. Now, what's going on is that if I want to be more confident, I'm going to give myself more room for error. If you demand less confidence, then I need less room for error. So that's what's happening. And going from 95 down to 90, or 99 down to 95, you don't need as wide of a confidence interval because you're not expressing as much confidence in your answer. Last but not least, we had two data sets here, and you're asked again to try and find some confidence intervals. The first one was the age of unsuccessful applicants. The second one was the age of successful applicants. And we compared them on two bases. The first one was their average age. So is there a difference in their ages? Well, that difference in their ages wouldn't reflect anything about variability. It's not reflecting something about proportion. So even though it's not said directly, you're kind of left with the conclusion that you have to be talking about the mean. And we can come up with a confidence interval for the population mean is somewhere between here and here for unsuccessful candidates. If you do that same thing for this data set, we'll end up with a different confidence interval. But the thing that you should see is that those two confidence intervals overlap. And if they overlap, we can't say that one of these is really different than the other one, because they could both be true in that interval where they overlap. Likewise, when you talk about how the groups vary in their ages. And the clue to use the confidence interval for standard deviation is you're talking about the way they vary, their variance, how spread out they are from one another. And what measures that is the standard deviation. So we do a standard deviation there. I think I've got that data in my data set, so let me just go over that with you real quickly. Analysis, confidence intervals, standard deviation, one sample. And there's my data. So, well, actually, you know what? That's the wrong, no, that is the right data. Okay. Confidence intervals, standard deviation, one sample. Instead of using summary statistics, you're actually going to use the data. So you click this and just tell it what column it's in. Now, in fairness, we should probably be checking to make sure that our data follow a normal distribution. That is something that I'm going to ask that you work on. But assuming that these both have a normal distribution, which you're going to have to check for yourself, either by looking at a histogram or a QQ plot or both. Let's find some confidence intervals. I'll do it for the first one. You can check me with the second one. Here's your 95% confidence interval from about 5.6 to 10.2. Okay. If you do likewise for your other group here, the successful applicants, their standard deviation of age, again, you see some overlap. So based on the results, can we say the two groups are different in the way their ages vary? No, we can't, because those two overlap. So that's it.